That's cool. Thank you. And thank you for the kind introduction, Stefan. And it's quite a topic you asked me to present, a very important topic. The energy transition is something we all should be very concerned about. There are still coming in challenging news that our actions to cope with the climate challenges is urgent. From the highest hold with United Nations, Antonio Guterres came out this month and telling about the importance of this, addressing this. So this is news all around the world. But I guess, like you, there's been a lot of news like this for quite a few years already. So we might be a bit tired of warnings. Might be a bit tired of hearing about all the threats and everything is going south. But if you think about now is the time to act, I think, at least for me, try to engage in this, try to understand how big the challenge is really, try to figure out whether there's any kind of plan out there to cope with this, and then lately, how can I help to actually join this plan and see how we can cope with this. I am not an expert in these fields. I am Espen Krogh, the CEO of Predictor. Predictor is a software solution supplier to companies that are heroes in the energy transitions, the ones building out new clean energy assets. So we need to understand how this transition might go about. So I've been studying a few analyses and listened to some talks that I believe is quite interesting, and I will try to convey those to you here. First, how much clean electricity do we really need? I've heard a very good talk on TED from Salman Goldstein Rose. We don't have the time to listen to his 10 minutes now, so I will try to condense it to a few minutes, but I will repeat the key message he has in his talk. So our current energy system is about 25 trillion kilowatt hours. And we need to go about and replace this energy system, replace the dirty energy assets with new renewable energy. Current renewable energy production is about 10 trillion kilowatt hours. So this needs to grow to 25 in order to replace those dirty assets. But it's still not enough to replace the dirty assets, because we also need to get rid of a lot of emissions from a lot of sectors, like the transportation and several other industrial sectors that needs to be electrified. So electrification will require an additional significant production of electricity in our energy system. And then, as we move forward, we expect to have significant rise of standards of living the next 30 years. And all those coming out of poverty, they will use more energy. They will buy cars like we have already in Europe, in the United States and other places. And this will again consume more energy. And then we need to condense the scale, because we need even more energy. We need also to figure out how we can replace the high density fuels that is used for airborne transportation. This can be done with liquefied hydrogen. And again, to produce this, more electricity is needed. The final leap of producing electricity and electric energy comes from the need to also cover emissions where we cannot reduce the emissions, like the agriculture. So then we need to capture CO2 and store it in places underground, safe, where it will not cause any more emission. So this is really the big challenge that we need to go and do. This is to build a new energy system that replaces our existing energy system within 30 years. That is actually 12 times bigger than our current renewable energy systems. So that's quite a daunting challenge. But quite a few specialist analysts have looked into how we can actually do this activity of going there and get this done. And a very interesting scenario, I believe, is provided by Rystad Energy. So Rystad Energy is a global energy analytical company. They have a global model with all energy production elements in, with all energy transportation and all energy consumption in that big mathematical model they have. So in this model, you can pick a scenario and then you can tune in the various activities of production and see how this folds out. So one scenario presented by Rystad in the Rystad Energy Week last autumn is the 1.6 degree warming scenario. And the 1.6 degree warming scenario says that we can limit global warming to 1.6 degrees. And this will then end in no more emissions or net zero emissions in 2056, with no more than 660 gigaton of additional CO2 emissions. In order to do that, it is 5 important technologies that needs to scale significantly. So we need to increase our yearly build of capacity within these 5 technologies significantly. Solar needs to scale from 200 gigawatt last year to about 1,000 gigawatt build out every year by 2030. And wind growing from 60 gigawatt last year to 300 gigawatt by 2030. Carbon capture, utilization and storage needs to grow from something rather negligible to a big industry, capturing 3 gigaton by 2050. And batteries from also a smaller 1 terawatt production last year to more than 20 terawatt by 2040. A hydrogen value chain needs to come in place and increase hydrogen production from about 70 million ton per annum last year to 350 megaton per annum in 2050. So is this realistic? Can we really scale these technologies to the level needed in order to address this scenario? Well, if you look at solar, solar has done a 5x scaling several times already in the history. The solar build-out capacity scaled 5x in 04 to 08, in 08 to 14, and 2014 to 2021. Hence, it's believable that we can still scale it another 5-fold from 2021 to 2030. But of course, supply chains will be rather stressed in doing this. So every body needs to be focused in the supply chains. Then global policies must stimulate the investment of more than $20 trillion in renewables. So this can sound like a rather big number of investments, but Rystad Energy tell us with this analysis that the number of investments needed every year is actually not bigger than has been invested in the energy sector the last decade in average. But the investments need to be channeled to these renewable technologies and not the dirty ones. So for this, we need the global policies. And happily, we have news coming in every month, I believe, on new policies coming to place in the bigger regions across the globe. This is happening. And also, we need all hands on deck. A lot of new technologies need to be built. New industries like carbon capture and hydrogen production need to build from almost nothing to significant and big industries. So the capable multidisciplinary engineering organizations like Refined and Oil and Gas need to join to try to do this. And this is also something we see in the news nowadays, is that all those former oil and gas operators, they have significant ambitions of switching to renewables and joining the energy transition. But let's focus and look at what this really means in solar and wind. Within the next 8 years, we need to build a significant high production of solar plants and wind farms out there. So what does it mean to build 1,000 gigawatts of solar plants per year? What does that mean in practice? Let's look at this site. It's Benban in Egypt. It was the world's largest solar park when it was built in 2019. Now I believe it's the fourth biggest or something. It's located in the Egyptian desert. It's quite close to the nearby Aswan hydropower dam, and it produces almost the same amount of energy. It's big. It's 6 by 6 kilometers in size, so it's visible from the outer space. In 2030, we must build a significant solar power capacity of 500 Benban-sized solar parks every year. So that's quite a big ambition. And what does it mean to build 300 gigawatt of wind farm every year? Well, let's look at this one. This is Doggerbank, the world's largest offshore wind farm, still under construction. It will be set up in the North Sea on a fishing bank called the Doggerbank, hence the name. And the total capacity planned in this is 3.6 gigawatts. And it will power 5 million UK homes with the electricity demand in those homes. So the actual structure of this asset is 277 wind turbines, of their offshore in sea. Each wind turbine is the size of the Eiffel Tower. And the area it covers is similar to that of Greater London, about 40 kilometers by 40 kilometers. By 2030, we must build the order of 100 Doggerbank-sized wind farms every year. But luckily, this might actually be quite financially efficient as well. We see now that both solar and wind are the cheapest energy assets to build with one specific investment. So it's actually 3 times cheaper than building new coal plants and 4 times cheaper than building new nuclear plants, and almost half of a natural gas plant. So they really compete with today's fossil energy production across the globe. Now, what does it mean for us, the OPC Foundation and the OPC community, that I believe many of the listeners associate with here today? First of all, let's pick one specific technology sector, the solar PV parks, and look at what is really happening right now with this. So our claim is at rather Klondike. Right now, we can read from project databases that register all new solar projects that there are actually now 898 solar PV companies planning to build big utility scale solar park across the globe. And actually in this database, you can find 1,855 solar park projects that are planned to be built in the next few years, totaling 536 gigawatt of solar PV capacity. This is equivalent to 191 Benban solar parks. And also, quite surprising, 85% of these companies are entrants, meaning they have limited prior experience in building solar PV portfolios. So they will also choose local suppliers to keep the cost down, suppliers of equipment, automation, and system integration. And what does this mean? Well, it means that a lot of these solar PV producer will need to learn very fast because they are coming into a very competitive situation. What they provide to the market is the ultimate commodity, electrons. They need to figure out how they can go about the continuous optimization of asset utilization and optimize their operations across their portfolio. So let's look at what that means. Optimization of portfolio asset management. So if you're a solar PV portfolio owner, you have in your enterprise, you might have several sites with solar PV parks. And it's essential for you to be able to adopt new technologies, new methods as they come about in order to optimize your operations. This will be a very dynamic field, and we expect a lot of new technologies coming in every year to be used to enhance the operations of these parks and automate it more and more. So right now we have topics like hybrid, renewables, energy storage, artificial intelligence, drone inspection, etc. There are many new technologies coming in to assist the operators of doing this very efficient. The challenge, though, when adopting new technologies is the quite diversified structures of suppliers you see in the specific assets. So typically, each supplier will set up a set of equipment exposing the data streams with some protocol and some specific context around the data that has become the standard within that supplier. So the challenge then to onboard new technologies is that all of these assets will then have a different structure and a different protocol maybe when you want to ingest and consume the data. You could potentially standardize on suppliers, but this will be difficult on a global scale. And it would also put you in a potential lock-in with specific suppliers. So the situation you're in then when you put new technology in your enterprise and you have like n new technologies you plan to take in and you have n different assets, you are looking at n times n manual integrations. So this is what we have called integration hell in many different industries. This is also now coming to the solar PV asset portfolio owners. One way to cope with this is to standardize on the local SCADA system. But still, this will put you in a lock-in situation with a local SCADA supplier. And we expect also a lot of consolidation will happen. There are significant scale effects and saving in that doing this. So when solar portfolios consolidate, there will be different SCADA suppliers in different portfolios. So this also doesn't solve the challenge. The solution to the evolving data integration challenge is this. When you look at the site, you will look at see that every site have more or less the same set of equipment types. You have a grid where you produce the energy to. You have modules. You have mounting structures. You have string combiners, inverters, transformer stations, etc. So you can create an information model with types that address the typical setup of a solar plant. And when you have the complete description of all types you can use and you put the interconnections between those types together, you have an information model. And this information model could then be used across your portfolio in each and every asset. And the data streams, when they arrive at the enterprise, they will then be contextualized with this specific standardized information model with standardized types. So this assists you a lot in coping with the integration challenges, and the experience of putting new technology into the enterprise becomes much more like plug and play. The technology that can do this for you is, of course, OPC UA. As we know, OPC UA has a set of protocols you can choose from, and within those protocols, you can contextualize the data streams with standardized information models. But still, looking at the Klondike that happened with the gold rush a few hundred years ago, we certainly believe this is happening right now. This Klondike is most likely producing a lot of chaos now in terms of information structures and being different across all the different projects and the different suppliers and the different operators that are now building solar PV plants. OPC UA is the right technology to standardize and use for all those operators to cope with management, operation, and optimization of the renewable assets. So we in the OPC Foundation and the community around this, we need to come together to publish a set of OPC companion specification for the energy transition to be used across all those thousands of energy projects that are now underway. So thank you. That was my view on the energy transition and what we need to do in the OPC community in order to assist with this. I will tell a bit more detailed about what we in Predictor are doing together with a couple of clients that have actually set up this Benban solar park and the Doggy Bank offshore wind farm. And they are using OPC UA at scale. I will tell more about this in the Thursday session. Thank you.